Good morning, folks, and welcome to the Safe Australia online meetup. Today we have Robin Yemen here. Robin and I have been trying to work out how we met and how long we've known each other, and we ended up with a long time, and we're not really quite sure. Somewhere around 2013, 14, 15. Probably at an Agile Alliance conference, definitely caught up at a DevOps conference. Very hard to know. We run into each other. We established that when I first met Robin, she was what we call a purple shirt, one of the volunteers at the Agile Alliance conference. So I don't know if it's the first time we met, but that's the image in my head. When I think about when did I meet Robin, I remember a very, very happy, smiley purple shirt. From 10 years ago now. Anyway, these days, I don't know. In fact, it's so funny. I have no idea what fun title you had back then, Robin, but these days you have the best title. Was it Space Domain Lead?
Yeah.
That is just awesome. She used to have an equally as awesome title. I think she was Safe Fellow, was it? At not Space
Fellow at Lockheed. Yep. Space and Safe.
So Robin does lots of really smart things with cyber physical systems. And I heard her talk at the Safe Summit in Nashville a couple of months ago, and I thought it was very cool. So I asked her if she'd come and share her story with us as well, because, it shouldn't just be for me. It should be for everybody. So usual drill, folks, if you can put cameras on, that is wonderful. Helps Robin see who she's talking to. If you have questions as we are going, feel free to raise your hand, which should bring you into Robin's line of sight. If you are shy or don't want to be captured on a camera and you want to ask a question, drop it in the chat and I will ask it for you because I'm nice that way. And on that note, Robin, they're all yours.
All right. Okay, I'm going to share my screen, and you guys are going to tell me if it works. Aha. Hello.
Hey, perfect.
All right. So, just as Em said, we've known each other a long time, and before this, I spent 26 years working at Lockheed Martin. I have built lots of systems, but primarily they've all been cyber physical, so large kind of software defined, hardware enabled. And so I'm really heavily focused on how do you implement Agile for large scale, safety critical cyber physical systems. And so with that, I will tell you about this really cool company that I've been volunteering with. And I've been volunteering with them primarily because, I had a cool picture too. I've been volunteering with them because I am working on my dissertation. So I've completed all of my PhD classes and someday I'll graduate. But I am working on a dissertation, which is how to deliver cyber physical systems using Agile and DevOps. And the background is, as you probably already know, we've seen a lot of success from Agile with small teams, small initiatives, building software. So you've seen everything from reduced product timelines, reduced schedules, reduced cost, increased morale, and transparency. So I'm working with this company, and they're called Orbit Fab. They're a startup, and they've actually have gone ahead and been able to fuel the International Space Station once. So that's kind of cool. They do have that under their belt. And they're building Rafty. Rafty is basically gas stations in space. The goal is to build refuelable satellites, which is going to extend the life of those satellites, as well as reduce orbital debris. That's a big issue right now, especially in what we would call low Earth orbit, or LEO. Here's a little bit about Orbit Fab. They were founded in 2018. They're in Colorado. They're actually pretty close to Safe headquarters. As I told you, they were able to supply the International Space Station, But their big thing, their big product that they're working right now is in-space propellant, right? So satellites can be refueled there. They've got a number of supporters. So companies like Lockheed or Northrop work with them so that they can make sure that they build their satellites to be refueled, because that wasn't the initial intent. So they're not really built that way. And then they can use them. So why do they want to go to Agile? And it's pretty much just like the rest of us, right? It's a highly complex domain, and they're constantly getting changing requirements. I mean, things are changing all of the time, and they need to deliver faster, right? So there's lots of good reasons for them, just like software. So here you can see their Rafty product, and the Rafty product is what helps refuel. And Rafty has a number of portions, but they're applying Agile across their teams to build these refuelable satellites so that they can deliver faster, higher quality, and meet that changing demand. Interesting thing, maybe you know, you don't know, in 2022, across the world, 547 billion invested in the space industry. It's expected to grow 40% in the next 5 years. And what I will tell you from a US perspective, talking to one of the generals, he said that we will see the change in space change more in the next 5 years than we've seen in the last 45, right? So they have all of the same problems that many of us moved to Agile for software for in the first place. All right, so we call this a VUCA environment: volatile, uncertain, chaotic, ambiguous. I mean, that's exactly what it is. They're constantly getting changing requirements. Like you said, orbital debris is growing nonstop, so they have to, change launch dates and things based upon, different aspects in the sky, weather. They have to, again, meet changing demand. Materials are moving really quickly as well. You've even got new entrants into the space market, so Relativity, SpaceX, who are 3D printing entire launch vehicles. So there's a lot of change here. And, typically for a large system like these, you're looking at a very long lead time. So being able to make change, constantly with a typical waterfall approach is impossible, right? By the time you've gotten all the way through your designs, you're having to change again, right? You'd never launch. So they really need to move to this and be able to, make it work. So I offered to train them for free and coach them if they would let me have data. For those of you who have ever tried to get your PhD or dissertation, data is like gold. Nobody will share data other than it's good or it's not so good or something like that. So that was the trade we made, and that works awesome. Here's their high-level goals. They want to be able to adapt to changing requirements. They've got multiple different customers. So they've got the Air Force Research Laboratory, but they've also got NASA, and they've got some international customers. So they have to be very adaptable. They have to be a bit more predictable than they are. When I first was talking to the CEO, he said for one of their programs, they had 10 months left to complete the work. And after 8 months, they asked for another 10 months. He goes, how could they be off that much? Because they're not looking at their data. Pretty much just like us, right? We don't always estimate correctly, and then we don't validate those estimates, and we're always looking at the happy path. So they need more predictability. They have to be transparent, and most of all, they need much shorter schedules. There are actually, some companies building satellites that are able to launch every few months, right? So it's a pretty tough market at this point. They're not huge. They've got 6 teams, approximately 7-8 people per team. And the products that they're building are Rafty, Grip, which is basically something that obviously grips to the satellite, and Core. And that's a lot of the software piece. I put them on 1 week sprints. I was going to do 2 weeks, but they were like, let's go for 1 week. I was like, wow, I don't often run into teams that are that excited and willing to go with 1 week sprints. So cool. So we did that. The experiment was to transition Orbit Fab to Agile and that it would help them in these areas, right? So the actions we took are, initial leading safe class. And then I did some lunch and learns to follow on because safe is awesome, but as far as the large solution layer or, that systems and hardware engineering, in some cases, it's still glossed over a bit and they really needed tactical. If I have to machine this part, how do I do that? How do I get feedback on that? We documented the known cyber physical challenges, and then we selected the practices that would overcome those challenges. In my PhD, I've been evaluating like all of the things, all of the practices associated with Agile, and there's roughly, if you were to add them up, about 100. You'd never implement them all, but they decompose into about 100. Once I add the DevOps practices, I counted up to 138. Again, you're never going to use them all. You're only going to pick those practices that you are trying to use to solve the problem, right? So what's the problem? Their problems was they needed the ability to adapt to change, increase transparency, improve predictability, and reduce schedules. So typical challenges that you're seeing in these cyber physical systems is organization and language, less homogeneous teams. When I say less homogeneous teams, I'm really talking about, in software, there's a whole variety of different types of software engineering. You get front end, you've got back end. Once I get to hardware, I get even larger because I've got electrical, I've got physical, I've got thermal. So it's not enough to just say hardware. I have constraints of physicality. How do I get that feedback quicker? The cost of learning. Every large-scale cyber physical system usually has quite a bit of regulatory compliance that we have to react or respond to. And then tool integration, right? And that's a pretty common problem for software as it is, but once we get into hardware, really, none of these tools talk to each other, which is a problem. So these were the practices we picked. First, cross-functional team. Why did we pick cross-functional teams? Well, because we really want to shorten those lead times and increase the learning. Same thing with pairing. We went ahead and did collaborative group planning. They were planning all independently, but again, they were having a lot of handoffs due to the dependencies. So here, when we planned together, they could see that. Time boxing. So 1 week sprints, time boxing really impacts predictability if you use the data, because it's really showing you how much you can complete within these timelines. We created features, stories, and tasks with definitions of all of those. Modeling so that we could visualize the work, visualize the system. We went ahead and changed our approach to the system to build requirements from a test approach, right? So we wrote them from how do I test, which really reduces a lot of rework. We leveraged demonstrations, retrospectives, and then obviously they're using a tool to visualize the work. They're using Jira to see their workflow. You can obviously pick a whole number of tools to do the same thing. Typically, one of the things I see, and they were no different, we have an organization and language problem, right? Program managers often are talking about things like lean. They might be talking about the PMO, maybe some finance stuff. Systems engineering is referring to things like systems thinking, right, to create their requirements. Designers typically are using words like design thinking. Hardware engineering, you're going to refer to them or hear them talk about rapid prototyping. In software, you'll hear quite a bit about Agile. In test, you're going to hear people talk about shift left. And in operations, often we're talking about something called ITIL, or IT Infrastructure Library. Now, here's the key. Each one of these organizations is actually trying to optimize the flow of delivery. However, we're not talking the common language, so we're talking right past each other. All right. So really getting these cross-functional teams to talk a common language was a big deal. Right? Because the flow of value is actually this way. So the collaborative planning and the pairing for Orbit Fab really allowed them to kind of learn this across the entire space. Remember, they're not a large program. They're maybe like for a company less than 100 people. Coming from a Lockheed Martin with 120,000 people, they're not huge. So they have the ability to look at this from a system perspective. If I was looking at a much larger system, which had, 10,000 people working on it, then maybe I would decompose, well, I definitely would decompose it into kind of subsystems and have cross-functional teams around those subsystems or complex subsystems. But they were able to, given the size of theirs, just to have cross-functional teams on this system. They moved from functional teams to cross-functional. They were just like everybody else. They had a PMO, they had people that are doing the finance, they had software, they had systems. They were all working separately. And then they began pairing. The part that I thought was really great is even the software engineers in some cases were learning how to machine parts. And I bet you that's not a normal thing. But they actually loved it. I think partially not because they ever planned to machine parts for a living, but just so that they understood, what was happening downstream and why things maybe took longer, why things needed lead time. So they got some good benefit that way. We talked about this challenge too. So that less homogeneous teams, all right? Once we get into a hardware perspective, not just a software, and I used to complain about this because I would tell people, well, you don't actually have the same software engineers, right? We had front end, back end. But as I learned larger systems, I realized mechanical, power, FPGAs, electronics, thermal, RF. I'm not even covering them all. Micro systems or microcomputers. So there's so much that is specialized in these hardware teams that having, let's say, completely cross-functional in some cases doesn't work out. And so I really looked to team topologies and how they talked about the different types of teams as well as the different interfaces to help solve this problem. So in some cases we had a feature team, but in other cases, we had, a complex subsystem or even, a structures team that's really just focused on the materials, and maybe they've got electrical, thermal, and hardware. So the practices that helped here, again, that pairing was huge. And given that they're a startup, they were really open to this. And then training. So cross-training in different areas. We always talk about this, but I don't know about you. Most programs I run into say, yes, we're going to do cross-training, and then life gets really busy and all of a sudden there's zero capacity to learn anything than what's in front of you, right? Basically the last minute, being able to squeeze something in just takes precedence. We definitely had to deal with the constraints of physicality, right? So the cost to make change does increase with hardware. The cool thing here is we've got some new tools in our toolbox, and they're not all brand new, but they've drastically improved over the last 20 years. So things like simulators, emulators, digital twins, digital shadows, even doing some 3D printing allows us to get rapid feedback back. Before, if I had a circuit board, I'd have to send it out, wait for it to, get done, then come back, then validate it. Now you can get this is what Harry tells me. I haven't actually tried this. PCBs in a day, right? So printed circuit boards in a day. Well, that's pretty darn fast. But I absolutely saw, with these teams, how leveraging lightweight digital twins and doing some 3D printing really allowed them to get much faster feedback. They didn't have to wait for the entire system. And when they were trying to validate things like designs, I was like, well, what if we validate the valve, right? So a small piece that we can look at within a week, but we're looking at the whole thing, so not all of the designs, but a little bit of design, development, and test for the valve, right? A small piece of the satellite. So here we increased modeling during the sprint. So we did leverage things like Cameo, which is a modeling tool, and some SysML. Now, right-size modeling. The reason I say that is because my experience in some cases has been that we have programs with entire teams of just SysML modelers, and all of a sudden the model becomes the proxy for the real product. So they're less concerned, in some cases about building a product because the model to that team is. So we want to make sure that we do just enough modeling, right, that's going to communicate the system, but we don't create endless exquisite models that aren't going to be maintained, because what happens is you create drift in the system. It becomes shelfware just like anything else. And so your actual physical system doesn't marry up to the model anymore. So I would tell you, always travel light. And then we did spend quite a bit of time, and I built some training just on this, on how to build features with good acceptance criteria. You know what I'm talking about. You've seen those features where it's a one-liner and you're like, maybe I know what you're talking about. So they kind of had the same thing. So we really focused on making sure that we had good definitions on those things, and that really helped them. We decreased the cost of learning. So leveraging models and digital twins allows much faster feedback, right? I can't launch a satellite every week and I can't get data back from it. So I want to take the physical system and move it into cyberspace. You're seeing the exact same thing with a lot of the car manufacturing companies, BMW, Mercedes. They're doing a lot of this type of work, all because, maybe they probably didn't say this, but Tesla kind of really started it, and they're like, hey, we've got to keep up. So much faster feedback on learning what's going wrong. And that's the same with this team. So things that we were able to do in this arena is obviously time boxing. I find that to be really helpful. So sprints are very helpful in being able to get fast feedback, because you have that retrospective, which forces you to look for just a minute even on what you did. Demonstrating real working product, that retrospective from the lessons learned, and then introducing a lightweight digital twin. Digital twins come in a range of fidelity levels, so they can be very expensive, meaning you can go all the way from a model with one sensor to a very exquisite digital twin that's fully, outfitted with complete telemetry. It depends on, what you're building. I'd need a different digital twin for, let's say, the F-35 than I would need for, something that is less safety critical. They absolutely had to deal with compliance and regulatory requirements. Here are the NASA requirements, and they have a number of these safety requirements. I did actually do an evaluation through my dissertation on a paper that looked at the European space standards, and of the European space standards, they found of the 216, they were actually looking for places where Agile was a conflict. Of the 216 safety standards, only 17 were in conflict. That doesn't sound bad, but it gets even better. Of those 17, the only ones that were in conflict were because the standard itself referred to a specific phase gate, meaning it wasn't actually a safety thing for the system. but a phase gate in that safety requirement. And if we could find another way to validate the system instead of at a phase gate, it wouldn't be in conflict either. Again, for them, we did, good feature story task definition with non-functionals. So we made sure that those compliance requirements are in there. And I always say begin with the constraint. So we basically built compliance tests from the beginning to make sure that I didn't have to go backwards in the value stream. The last really big challenge for Agile systems typically is found in the tooling, right? And we see this in software, but it gets even worse in hardware. So we want to be able to visualize our work. We want to be able to see that, but our tools don't talk to each other. Now with these guys, in some cases, we had to do some manual mapping, stuff like that. If you had a lot more money, you can leverage tools that were built just for this. So Plutora is a good one. TaskTop is great. They're now at PlanView. And they're actually built to actually integrate these tools so that I can see the entire value stream. Like I said, we did old school whiteboarding to do some mapping, and then we definitely integrated Jira with a Microsoft project schedule. Some of you, especially if you're very big into Agile, will be like, oh, we're anti-schedule. I'm not, but at a higher level. Meaning I don't want a schedule that tells you what Robin's going to do on Thursday, the last week of October in 2027. But I do want a high level roadmap, right? For example, SpaceX, they want to hit human spaceflight in 2026. They've had a series of experiments to get them there. So the difference between a schedule like this and a integrated master schedule that's typical is that we have regular feedback loops to adjust and adapt this schedule to based on what we've learned. All right. But for things like space systems and large vehicles and aircraft, these are multi-year projects. And so it can get lost if everything's just in a backlog. All right. So they saw a lot of benefits at Orbit Fab. They were able to adapt to change. People loved the transparency and the predictability. Obviously, they're still having some challenges, but I will tell you that they were really, from a time perspective, and they're understaffed just like the rest of us. So they had trouble taking time away for training, which is why we did lunch and learn so we could impact that less. And they've still got a lot of really tight schedules, working with the leadership to make sure that they don't commit on behalf of the team. I know that never happens in your world, but in my world, some leader comes along and says, yes, we'll do that. And then everybody's got to make it happen. So they've still got some of that residual that's impacting them. Let's see that. All right. Some things that I hadn't expected. Much higher customer confidence. So in the past, the customer wasn't able to see some things. So this added transparency and the demonstrations every week really changed the relationship with the customer. The team morale, they felt like they had some control over the life, so that went up. And they're really starting to see how different milestones intersect just by visualizing their work. So that was a huge benefit for them. All right, so I would say, yeah, we can use Agile to build gas stations in space. I'm still working with them, and I'm now starting to work with some other companies. But the answer is yes, we just have to rethink some of those practices and maybe in some cases bring them up a layer. So we're going to continue to get better, increase just-in-time training. They're going to add more teams, really leverage the empirical data from their schedules to bring back into their estimation for future. So that's goodness. Lastly, we actually just released a book on this, Industrial DevOps. It came out October 10th. But if you take a picture of this URL, you can get the first chapter for free for excerpts. And obviously this is my safe summit session, so you don't have to rate it, but any questions and feedback would be awesome.
Thank you so
That's
much, Robin.
welcome.
That was just as much fun, if not more fun, the second time. I don't know if either you did it better the second time, or because I had pre-calibrated myself, I heard different things and it was very fun. So thank you so much for that. A couple of questions in the chat here. First one is from Junaid, who would like to know the size of the team that was reorganized around Agile, how long it took to reorganize, train, and adapt.
So the size of the team was roughly less than 100 people. The teams themselves were about 70. They had some leadership and stuff like that, so we did do that. How long? Well, we're still doing lunch and learns, but we did the initial 2-day training in May, and from then I've been doing bi-weekly lunch and learns, and I attend their retrospectives and their demos. So they're still in progress. They've already seen some results, but we all know this is kind of a journey. When your company comes back, and goes, yay, we're agile, you're probably scared.
Thank you. Lots of nice thank yous and things. Also, can you please, this one from Chris, can you please elaborate 1 week cycle and the ceremony modifications to suit that?
Yeah, so usually I just do that as a percentages. If you were to look at a 2-week sprint, right? A 2-week sprint typically would have an 8-hour, not everybody uses it, but an 8-hour sprint planning. And I do use it. The reason I say this is because I find that there's only, it's not a meeting. It's actually where you do detailed design in Agile, and that it shouldn't be short-sighted. But for a 1-week sprint, we went to 4-hour planning. For our demonstration, we went to 1 hour, and for our retrospective went to 1 hour, and then the daily stand-up stayed at 15 minutes. We kept those the same. But it's more of a percentage wise.
Thanks, Robin. It's so funny when you say, no one ever wants to do 1 week. And I think about working with, cyber physical, and it's always, can we do six weeks? What are you talking about? 6-week sprints, not only 1 week sprints.
I find it's mostly because people don't know how to decompose their work, right? And they can't extrapolate the fact that I don't have to deploy every week. I'm trying to get feedback every week. On the cyber physical systems, I'm really trying to buy down risk.
Yeah, absolutely. I used to work with a guy who would say you'll never get any better at delivering in 2 weeks unless you start trying to deliver in 2 weeks. And I think it creates an awesome function for breaking down the work.
It's true.
There is a question from Lim. Hi, Robin. How involved is the senior leadership team on this journey, and does it take some convincing?
So typically I find that it does a lot of convincing, but in this particular case, the CEO reached out and asked for this. So he was 100% bought in. It's a startup company, so it's a small leadership team. So they were kind of all really excited and bought in. My experience at Lockheed for many years, usually I have to do a lot of convincing. So not in this case, but usually.
Thanks for that. One from Sam. What approach to MVP prioritization do they adopt in this industry?
So this is how I explained MVP to them. And I find that a lot of people really misunderstand it. So when you read Lean Startup and Eric Ries, he said, an MVP is enough that I can learn something from it. He never meant for, it to always be deployable, meaning like if I'm building an app, I could probably deploy it and get some feedback, but I'm obviously not going to deploy that to, a satellite once a week and get feedback. So what was the MVP? For example, I said, hey, how about we get feedback on the valve? Like they had to design the valve, have a review on the valve, and then interface the valve with some software. So from that perspective, that was an MVP. It was enough to learn on, and it allows us to go and do that next bit of learning. And I think this really ties back to the new book, which I just got from Dr. Spear and Gene Kim, where he talks about simplification, amplification, and one other thing, and really they talk about take your system, decompose it, and move the novel pieces out, meaning the pieces you don't know anything about that you've got to experiment on, but the other pieces, go ahead and work that. And I find that that's exactly the same thing, because we've built lots of these systems before. A new system has novel elements, but not the whole thing. So I when I started reading that new one, I was like, oh, I wish, and they articulated it so much better than I did. I was like, that's awesome.
Thanks, Robin. I'll drop the link to their new book and your book in the chat for folks. Dave says, hi, Robin, can you talk a little bit more on how you generate and maintain the compliance package to get something into space?
So absolutely. And unfortunately, or fortunately, however you want to say, it's not all digital. I'd love to say that NASA is all digital. They're not. But basically, we identify all of those compliance requirements up front. Some of them are, proving things with the digital system. Others are artifacts, and basically check them off. You'll find that actually many of them are iterated through anyway. They just never really talked about it, because they'll try to implement, let's say, a security item on a system, and they'll talk to what we call the AO, or the approving authority, and the approving authority be like, yes, oh, this isn't quite right, and then you iterate on it again. So basically, create a package with the checklist and integrate that in with the team, and validate pieces of the compliance package instead of building the whole system and then hoping it complies at the end, which I've totally seen.
Thank you, Robin. Chris is back. Can you please touch on the documentation with this hybrid approach?
Documentation. If I answer the question right, so you tell me, because I want to make sure I understand you. But when building a cyber physical system, I need as much documentation as it takes to design the system, communicate that system to other people, and to operate it and sustain it. Some of the systems that I've worked on have been around for 50 years and will be around for another 50. So I need that much documentation, but I want to right size it. And so I'm not anti-documentation, but I am about right sizing it. Now, what do I mean by that? Not to make fun of my country, because I'm sure you've got some of these stories of your own, but the US has these things called MIL standards, right? The Department of Defense builds a military standard for everything. Well, believe it or not, they have a military standard for chocolate chip cookies, right? So you guys have built or baked chocolate chip cookies before, right? You probably have. All right, so if you were to read the MIL standard for chocolate chip cookies, it's 38 pages. Now you might think to yourself, you might not need 38 pages. I actually thought the half page, on the back of the chocolate chip package was good enough for me. So they're both documentation. So when I say right size, I need the amount that somebody's actually going to leverage, actually use for those systems. But it doesn't mean I need endless documentation, like 38 pages to bake chocolate chip cookies.
Want to see that document?
I will send it to you.
It
tells you how to exactly chop your walnuts just right. God forbid you didn't want walnuts in your chocolate chip cookies. I don't know.
They're not optional?
It's not an option. It's just, there's one way to do it, and it takes 38 pages.
Brilliant. A live question. Go ahead, Shama.
I suppose they don't assume anything. They want everything laid out to cater for everybody.
Yes.
Oh,
I can't hear you.
That's really to hear.
Shama,
Sorry.
you're breaking up.
Can
You'll put your question in the chat.
you? Okay.
Almost a live question.
It's like demonstrating a live system. I love doing that too. What could go wrong?
Sam, where in the safe configuration is the team at? How do you get to the next stage and why?
Well, so I usually use the safe configuration. Well, I think as it's meant, meaning, I use the team level, and I use the program level. And honestly, there's elements up in the organizational level or the portfolio level. They're there, like, for example, system intent, because that's where it fits in the picture. But it doesn't mean I don't need system intent at the team level. And if I don't have a large enough program and I'm not having a portfolio level, that I wouldn't have that model-based systems engineering and system intent. So typically I take the elements from the framework, again, to solve the problem, that I'm trying to solve.
Here's Shama's question. Which of the changes you implemented did the team find challenging and how did you support them?
The biggest one, and this they're still working on, the biggest one is decomposing the system, really being able to break it down in a way that you can actually validate portions, because typically, you would do all the design right from a waterfall perspective. So showing them how to break it down, and then also estimation. And they're getting better at it all the time, but it was definitely the hardest part. And it's kind of why, if you guys are familiar at all with Harry Kahneman, that he's got the cyber physical working group, and he wants people to put out examples of decomposed systems, because that seems to be a common problem across everybody, is how do I break down the work so that I can actually implement something in a sprint?
Thank you, Robin. Physical system.
Yeah, like a satellite's a physical system, or a car, or anything like that.
Awesome. All right, I think we've drained the question pool in chat. Unless anyone wanted to add a question in chat, or someone wanted to try another version of, live asking questions.
And you can feel free to just, if you find something later that you're like, hey, I wish I'd asked this, you can email me.
She does reply. It's true.
I reply.
All right, folks. Thank you so much for joining this morning. Lots of lovely feedback for you in the chat there, Robin.
Awesome. Thank you.
Very much enjoyed it. And I don't know if you caught earlier in the piece, in addition to the folks on the call, there are another 20 folks in Sydney in a room with Adrian and Claire. So you actually had double the audience you can see.
Oh, awesome. Well, thank you.
But oh, yeah, there's Adrian. The team here really liked it. There you go.
Oh, very cool. Awesome.
So yes, thank you so much for joining us, Robert. It's so fun to hear that again. Thank you, everyone, for coming and listening and asking questions. Meet up, folks. No doubt we will see you again probably in around a month, when I talk somebody else into coming and chatting to you. And Robin, no doubt we'll talk, because we do.
All right. I will talk to you guys soon. I'm going to head back to the conference.
Thanks, folks. Thank you, Robin. Bye.
Thank you. Bye.